In 2000, the population of the world was 6.1 billion, and the relative growth rate was 1.4% per year. It is claimed that a rate of 1.0% per year would make a significant difference in the total population in just a few decades. Test this claim by estimating the population of the world in the year 2050 using a relative growth rate of 1.4% per year and then 1.0% per year. So our exponential model is P of t equals P naught e to the RT. So if our 1.4% is our relative growth rate, that's just R. P naught is the initial population, and we're working with billions here. So I'm going to just put 6.1, and we're remembering that we're talking about billions here. And then e to the R is 0.014 t. So there's our model, and we want to know what the population would be in 2050. So that's 50 years after our initial time, which was 2000. So we're looking now for P of 50. So 6.1 times e to the 0.014 times 50. Let's go ahead and plug this into our calculator. 6.1 e to the 0.014 times 50 and that gives us, we'll round to the nearest tenth here, 12.3. 12.3, and this of course is in billions. So using a relative growth rate of 1.4% per year, we'd estimate a population of about 12.3 billion in 2050. Now for the 1% per year, we have the same process. R is the only thing that's different. So we have 6.1 e to the 0.01 t, and we go ahead and plug 50 into that. So 6.1 e to the 0.01 times 50. And now we can plug that into our calculator. 6.1 e to the 0.01 times 50. And we get, round to the nearest tenth, 10.1. So 10.1, and again, that's in billions. So we see here that with this change between a growth rate of 1% and 1.4% per year, in 50 years, the difference in the population is over 2 billion, which is pretty significant.